So greetings everyone. This is Nikunj, Singhal and Lakshya Agrawal, and today we are presenting our work done in collaboration with Dr. Raghava Mutharaju, which is titled A SPARQL to Cypher Transpiler, Proposal and Initial Results. So let us start by the motivation behind our work. So like it has been seen that the two most common graph models are the RDF, or the Resource Descriptive Framework, which is a W3C standardized graph model. And SPARQL is the query language used to query RDFs. And second is the property graphs, or PGs, which is the non-standardized model. It is directed edge labeled graph with key value properties as an additional flexibility. So a common problem that has been seen is deciding between the two models. And this problem is very complex due to considerations on data modeling and query language features. Approaches to interoperability so far have focused on converting RDF to PG directly. And a new graph data models have been proposed that can be queried by both languages. This requires very expensive data conversions, especially for large data sets. We propose a SPARQL to Cypher transpiler, which avoids this expensive data conversion. This whole process is demonstrated in this diagram over here. We have knowledge graphs. On the left-hand side, we have RDF and SPARQL as a query language. And on the right-hand side, we have PGs and Cypher as a query language. In the middle, we have a user which is confused and he wants to decide between one of these two graph data models. And our work, SPARQL to Cypher transpiler, acts as a bridge by allowing to convert the SPARQL queries into Cypher, which allows the user to query the property graph databases. All right. So we established in our work the dependence of query conversion on the schema conversion. So it's, as you can see in this diagram over here, in the middle, we have an RDF where we have this A node, which knows some literal John Doe. Now this RDF can be converted to a property graph in two ways, which is shown by conversion 1 and conversion 2. Now corresponding to these two conversions, our middle SPARQL query, which is shown at the bottom, can be converted to corresponding Cypher queries. So we can see that the conversion to Cypher queries actually depends on the conversion of RDF to PG. Moving on. We have followed a three-step transpiler development approach, with step 1 being when we defined a custom RDF to PG schema. And in the second step, we basically modified it to support existing RDF to PG conversion schemas. And for the third step, we are building a generic transpiler that takes the graph conversion scheme as an input. As part of contributions of our work, we have developed a test bench. So following test-driven development practices, test bench is developed to test query conversion and validity. It initializes data RDF dataset in Jena and corresponding property graph into Neo4j, and compares the result of SPARQL query and the result of transpiled Cypher query, as you can see in the architecture here.
Considering the differences between the RDF and PG data model, a mapping language is required to map constructs in SPARQL query to constructs in Cypher query, in line with our third step to build a generalized SPARQL to Cypher transpiler. Actual conversion of the data is not required, and rather the transpiler needs to understand how the underlying virtual RDF would map to the property graph and hence convert to the SPARQL query to Cypher accordingly. The SPARQL query that is written by the end user can be simplified as a result of good mapping choice, as can be seen in the example below. We consider a simple property graph depicting flights from Delhi to Mumbai, and depending on the conversion schema, we obtain two different RDF graphs, as seen in RDF conversion 1 and RDF conversion 2. And the same query in Cypher, when converted to SPARQL for the corresponding RDF conversion schemas, can be seen on the right hand side. As we can see, the second SPARQL query is much simpler than the first SPARQL query, as is the second RDF graph. Hence, use of a mapping language simplifies the conversion requirements as well. Based on the mapping language and to build a generalized SPARQL to Cypher transpiler, we propose the following architecture diagram for a SPARQL to Cypher transpiler. The SPARQL query is passed to the Jena query parser, which builds the SPARQL AST. And the SPARQL AST is then passed to the Jena SPARQL algebra compiler, which then provides a standardized SPARQL algebra. Now we take the mapping file and pass it through a step called variable rule generation, wherein the various aspects of the model along with the graph modeling are captured in the form of variable rules, which are passed onto a constraint solver. Now the constraint solver provides us with a simple table which maps the various constructs in the SPARQL algebra to the various constructs present in Cypher language, like nodes, node properties, node keys, edges, etc. Parallelly, the literals are passed to a PG to RDF literal mapping schema based on the mapping file. The results of both of these steps are finally fed into a SPARQL algebra visitor, which visits the various various algebra constructs and creates the Cypher query incrementally. As a part of our future work, we are working on extending the SPARQL to Cypher transpiler to support more generalized mapping-based conversion, extending the test bench to support query performance benchmarking. Formal proof of correctness of query conversion is also being worked upon, and we will further release the tool as an open source public web application. The following are the references that we used in developing our work. Thank you very much for attending our presentation.